Today we are going to learn about similar triangles. We began a little bit working with similar triangles in our lesson last time, and we're going to dig a little deeper today. So there are three ways to show that two triangles are similar. The first one is called AA similarity, which is when you have two angles of one triangle that are congruent to two angles of another triangle. That's because if the first two angles are congruent, the third one also has to be congruent. So just knowing any two angles of one triangle are the same as any two angles in another will be enough to say with certainty that the triangles are similar to each other. The next one is SSS similarity, and that's when the measures of the corresponding side lengths of two triangles are proportional. So you can go little over big, like A over B equals C over D equals E over F. And when you set up your corresponding sides, they are all in a proportional relationship to each other, so the fractions are equal. And the last way is called SAS similarity. This is when the measures of two side lengths of one triangle are proportional to the measures of two corresponding side lengths of another triangle, and the included angles, which would be considered the middle angles between the proportional sides, are congruent. So let's see how this works. We've got some practice problems to do together. The directions say determine whether the triangles are similar. If so, write a similarity statement and explain your reasoning. So look at number 1. I can see that these two angles are congruent to these two angles. So this is going to mean yes, the triangles are similar. And the reason I know they are similar, to explain my reasoning, is by angle similarity. If two angles of one triangle are congruent to two angles of another. And then we have to write this similarity statement. So triangle ABC is similar to triangle. Now we need to match up the matching letters. So angle A is congruent to angle D. So since A is first, D goes first here. Angle B is congruent to angle E because they have the double arcs. So since B is the second letter I wrote down, E must be the second letter in the name of the second triangle. And then last, the angle C corresponds to the angle F, and it's congruent to the angle F. So that finishes off the triangle similarity statement, and we're done with number 1. All right, let's take a look at number 2. On this one, I have one pair of congruent angles, and then I have side lengths on the sides that are next to that angle. So I'm going to set up a proportion, little over big equals little over big, and see if these proportions are indeed equal, if the sides are proportional to one another. So little side 18 goes with the big side 20. And I'm checking to see if it is equal to little side 24, which goes with the big side 36. So let's check. We can use a calculator to do this. 18 divided by 20 is equal to 0.9. So 0.9. Is that equal to whatever this fraction equals? 24 divided by 36 is let's round it off to the hundredths place like money, 67. Okay, these are not the same, are they? So we're going to put a slash through the equals. This is not equal, this is not equal. So these are not similar triangles. These fractions have to be equal. If they would have been equal, we could have used the SAS similarity, side angle side, side angle side. But since they are not proportional these triangles are not similar. All right, let's look at number 3. This one is kind of tricky because there's no numbers on it and no angles marked congruent at all. Kind of crazy, but we do have parallel lines cut by a transversal, which means corresponding angles R and S have to be congruent. We also have the same parallel lines cut by a different transversal from U to T, so these angles U and L have to also be congruent because they are corresponding as well. And this is from information we learned back in Unit 3 about lines. So, since I have 2 angles of the big triangle congruent to 2 angles in the smaller triangle, I can say yes, these triangles are similar by angle-angle similarity. And now we're ready to write our similarity statement. So triangle RTU is similar to triangle STL. And remember, R was the same as S, so they're the first letters. T is overlapping, so it's the same in both. And then L and U are congruent, so those go last in each one. So we've got our similarity statement set up. Now let's take a look at number 4. I see we have a pair of congruent angles. They're 65 degrees apiece. Now we need to check to see if these sides are proportional. Okay, so we're gonna go little over big and little over big and see if they come out. So this left side 4, little side 4, matches up, corresponds to the big triangle side 8. And we're going to see if that's the same as the little triangle side 9, which corresponds to, matches up with the big triangle side 18. So are these fractions equal? Let's see. 4 divided by 8 is 0.5, and 9 divided by 18 is 0.5. So yes, they are congruent. And that means these fractions, since the fractions are congruent, the sides are proportional. So by side angle side, we have similar triangles. So yes, they are similar. Side angle side similarity. And when they are similar, we need to write a similarity statement. So triangle DKJ is similar to triangle PRZ. And that one is done. All right, let's move on to number 5. Are these triangles similar? Well, I have a pair of congruent angles, so this one is very much like the last one we just did. In fact, maybe you should pause your video and try this one on your own, see if you can get it. Then start it again to see if you got it right. Okay, so hopefully after noticing the angles were the same, you checked to see if the sides were proportional. So if you look at your little triangle and your big triangle, little triangle side 16 matches up with big triangle side 24. And we want to see, is this fraction equal to little triangle side 26 over big triangle side 39? So let's check in the calculator and see if those fractions are equivalent. 16 divided by 24 gives us 0.67. And then 26 divided by 39 equals 0.67 also. So yes, they are proportional. The fractions are equal and the sides are proportional. So we're going to say yes, the triangles are similar. They have side angle side similarity. And triangle FBE is similar to triangle LNM. All right, we just have one more. And guess what? This one is different. We have no angles marked the same in either triangle. So we are definitely not going to try to use angle-angle similarity or side-angle-side similarity. What we are going to try to use is side-side-side similarity. So what we have to do is look at our little triangle and our big triangle and set up 3 proportions. Little over big equals little over big equals little over big. And all 3 fractions must equal the same thing in order to say these 2 triangles are similar. So let's start with the shortest side in both. The shortest side in the little one is 15, and that should match up to the shortest side in the big triangle, which is 24. Then the medium side would be 20 in our little triangle, and the medium side in the big triangle is 32. Then the largest side in the little triangle is 25, and the largest side in the big triangle is 40. Okay, so now we're going to divide these fractions and see if they come out the same. 15 divided by 24, 0.625. 20 divided by 32, it equals 0.625. How about 25 divided by 40? That one also equals 0.625. Since all 3 fractions are equivalent, we can say yes, the triangles are similar by SSS similarity. And then we're going to write our similarity statement. Triangle GHI is similar to triangle QRS. Okay. Now we're going to do some algebra problems. It says first identify the similar triangles, which means we're going to write a similarity statement. They are not asking us to determine if they are similar or not this time though. They are telling us, yeah, they're similar. So just write that similarity statement and then find the missing measurement, okay? So for the first one, we're gonna say triangle XYZ is similar to triangle XY would go with JK and then L. And so here's my little and here's my big. I need to look for a pair of sides on both triangles that have numbers on them that are corresponding sides. So that looks like the 10 and the 20. So little side 10 goes with big side 20. And now we are going to look where our X is. The X is on the big triangle, so that's going to go on the bottom. And the little side that corresponds to that side X would be this 13. So little side 13 goes with big side X. Now we're going to cross multiply. So 10x equals 13 times 20, which is 260. And then divide by 10 on both sides to get x by itself. So x is equal to 26. And that problem is done. Okay, next we are going to do problem number 2. So we'll start by identifying the similar triangles. So we're going to have triangle GHW is similar to triangle GIU. And I want to give you a tip. Sometimes when they have drawn the triangles overlapping like this, it's a good idea to draw your own picture where the triangles are not overlapping. It tends to help students avoid some common errors. So I'm going to say this is GHW and this is GIU. So here's my little triangle and here's my big triangle. And what do I know? Well, On the little triangle, GW is 26 and HW is 20. And look, there's congruent marks on the top, so this is 26 also. On the big triangle, the bottom side, GU, is going to be the total of 26 plus 13, which makes 39. And since this is a double tick and this is a single tick, and this is a double and this is a single, the upper side would also be 39. And then the X is here. So we need to find a pair of sides that both have numbers on them, on the little and the big triangle. So we'll say the 26 for this one and the 39 for this one. So little side 26 goes with big side 39. And then the little side 20 would go with the big side X. And now we can cross multiply. So 26x will equal 39 times 20, which is 780. And then we'll divide by 26 on both sides. So x will equal 30. And that one is done. All right, we're gonna skip number 3 and we're gonna come down and do number 4. So on number 4, this one, we already know they're similar triangles, but to write the triangle similarity statement, we need to figure out which angles go together. So we'll say triangle ABC is similar to triangle. Now, which angle is the same as angle A in the other triangle? I want you to notice the parallel lines cut by the transversal AD. That means your alternate interior angles are congruent. So angle A is congruent to angle D. And then angle B, the middle angle in both, is congruent because those are vertical angles. And then angle E and angle C are congruent. So DBE would be the order we need the second triangle written in. So now we're going to look for a pair of sides on both triangles that both has numbers. So I'm looking at AC, the first to the last letter is 30, and DE, the first to the last letter is 60. So I'm going to say that little side 30 goes with big side 60. And then the X is on the little triangle, and that one is from C to B, so that's the last two letters. So from B to E is 38.6, so that's the side that matches up with it. And we're not going to use this number 23 at all. It's extra information that is not needed to solve the problem. So here we will cross multiply. 60x equals 30 times 38.6, which is 1,158. And then we'll divide by 60 on both sides. So x is equal to 19.3. Definitely feel free to use a calculator. All right, let's go down and we'll do number 5 together. And then I'm going to have you try number 6 on your own and then check to see if you get it right. So for number 5, again, we have this situation where we have overlapping triangles. So my advice to you is to draw the two triangles out separately. So KVM is your big one and LPM is your little one. So we have X from L to M and 16 from P to M, and we have 7.2 from L to P. Now on the bottom of the big one, we have to add these two together. 8 plus 16 is 24. So we'll have 24 on the bottom. There's no information on the left. And then the top from K to M is 9 plus X. Okay, so we're gonna have to go look for the big sides that have numbers on both. So that's 16 and 24. So little side 16 goes with big side 24. And then little side x goes with big side 9 plus x. So we have two x's in this problem, but we have worked proportions like this already in this unit. So we're going to cross multiply 24x equals 16 times, in parentheses, 9 plus x. And we'll distribute the 16. So we'll have 24x equals 144 plus 16x. And then we'll subtract the 16x on both sides. So 144 will equal 8x. And then, where am I going to go? Over here. If 8x equals 144, we'll divide by 8 on both sides. And that means x is equal to 18. And that's the answer to the problem. All right. I want you to pause your video and try number 16 on your, number 6 on your own. And then you can start it again to see if you got it right. Okay, hopefully you've done this. I'm getting kind of scrunched for room here, so I'm going to grab a separate sheet of paper to do this one on with you. So, let's see. I'll start by drawing the two triangles separately. Let me scoot this up, see if I can fit all this together. Here we go. FRQ, free response question, and FNP. So on this little one, we have a 32 down here and a 30 out here. On the big one, it's 30 plus 10, so 40 here, and 32 plus x on the bottom. And we have a 22 here, but we don't have a side that goes with it on the RQ triangle, so that's a number that we will not use to solve the problem. So the 40 and the 30 are the numbers where we have matching numbers on both triangles. So we'll go little side 30 goes with big side 40, and little side 32 goes with big side 32 plus x. So now we're ready to cross multiply. So 40 times 32 equals 30 times 32 plus x. And when you multiply 40 and 32, you get 1,280. And then you have to distribute the 30 here. So that gives you 960 plus 30x. So if you subtract 960 from both sides of the equation, you get 320 equals 30x. And then if you divide by 30 on both sides, you get x equals 10.67. Did you get it right? I hope so. All right, there's just one problem left in the notes today, and it's a little word problem. It says, the heights of two vertical posts are 2 meters and 0.45 meters. When the shorter post casts a shadow that is 0.85 meters long, what is the length of the longer post's shadow to the nearest hundredth? Okay, so we're making two triangles. We have a big triangle and we have a little triangle. Okay, so the heights of two vertical posts are 2 meters, that's the big one, 2 meters tall, and 0.45 meters on the little one. When the shorter post casts a shadow that is 0.85 meters. So 0.85 meters is the shadow going along the ground. what is the length of the longer post shadow? So there's your x to the nearest hundredth. So that means we're going to round our answer to 2 numbers after the decimal. So the sides that have numbers for both are the 2 and the 0.45. So I'm going to set it up. Little side 0.45 goes with big side 2, and little side 0.85 goes with big side x. And now we will cross multiply. So 0.45x equals 2 times 0.85, which equals 1.7. And then we will divide by 0.45 on both sides. And x is equal to 3.78. Since this is a word problem, we'll look back. These units are in meters, so we'll put the M for meters. That's the answer to the problem. All right, that's all I have for you today. Good luck with your similar triangles lesson. I hope you have a wonderful day, and just email me or let me know if you have any questions or you need any help. Bye for now.